I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life,
The podcast that helps you understand the chemistry of your everyday life. So if you're just now joining us or you've not listened to very many episodes of our podcast, Melissa really is a chemist. She has her master's in chemistry and she's getting her PhD and she teaches. And I am really not a chemist and I really don't teach or don't have any chemistry formal training of any kind other than a few classes here or there. And so what's about to unfold in front of you is a real life chemistry lesson to a person who really knows it and a person who really, really, really does not.
really does not. But you have learned a lot through the course of doing this podcast, actually, I think.
That's true. I kind of should probably start to adapt how I word that. So I do have the knowledge of all the other episodes you see in our feed. Yeah. So I guess, the emphasis on formal. Don't have the formal training, although I'm being taught by someone who has the formal credentials to teach me. So I don't know. You tell me, am I slowly morphing into a more chemical person?
You're becoming a chemist. Well, that's true. I am a chemist, but this week, the thing I'm teaching you is something I also learned about.
Oh, nice.
So one thing that we talk about sometimes is even though I'm a chemist, that means I have studied, I've learned, I am an expert in my field. But that doesn't mean I know everything. There's still a lot that there's left for me to learn. And one of the big things that I learn is how to know what sources are legitimate and what not, and how to think through solving a chemistry problem with all the basics of chemistry that I have.
Yeah.
So that's a big part of what it means to be an expert. It doesn't mean that I'm always right. It doesn't mean that I never make mistakes. It means that I have studied extensively and am using that information to make my best guess or to communicate to you guys. And that's what I did this week.
Nice.
So are you excited to hear the topic for this week?
Yes. More than anything in the world. Please tell me.
This is from a listener. She messaged us on Instagram. She's a listener and real life friend,
Whoa.
Katie J.
Real life friend, not just to somebody, but to you.
To me. Real life friend to me.
Yeah.
Katie J. And she said, why does Coke and Mentos do that thing? Which is such a great question. Just the way she said that thing. And it's like everyone knows what that thing is. So.
Yeah, true that. And also, it is much easier to say that and try to describe it. Like, what do you even say? It's like, yeah, it foams, but a lot and kind of explodes. I mean, it's like...
Yeah, makes a geyser.
Yeah, it's way easier just to say that thing.
Yeah, I think it's so funny that she said that. So, why does Coke and Mentos do that thing? And if you don't know the thing that we're talking about, stop right now. Go buy a 2-liter of Diet Coke, a tube of Mentos, quickly dump the tube of Mentos into the 2-liter and step back.
And do it outside, please.
And do it outside.
Your parents or housemates or whoever, spouse, will love you for doing it outside instead.
Or if you're really worried, just watch a video. But it's more fun to do it in person.
Truly is. It really is a lot of fun to do.
Okay, so I had never looked into this before, and I honestly thought it was going to be a pH question, which is acid and base.
Oh,
so
gotcha.
I thought soda's kind of acidic, and then maybe Mentos are basic, and so it's a very violent reaction with a few other factors, is what I assumed. We saw another acid-base reaction for what's the difference between baking soda and baking powder. That's what makes cake bubbly and light. So I thought it was going to be the same thing because it releases all these bubbles.
Oh, yeah. Gotcha.
Well, it's not.
Oh, really?
It isn't an acid-base reaction at all.
Interesting.
In fact, it's not even really a reaction in the traditional sense that we're used to at all.
Okay. Well, now that we don't know anything about anything anymore.
Now that you don't know anything. It's what we would call maybe a physical change. So all of the ingredients are there and there's no molecular rearrangement. There's no like new bonds forming or old bonds breaking. It's just basically all of the bubbles that were already there are forming super fast and escaping.
Oh, I see what you're saying.
All the ingredients are there already.
Yeah. it's just kind of changing the timetable of things in a way,
Yes.
speeding it up, whatever.
Yes.
Huh.
So all this has to do with physics, or in chemistry, we call this surface chemistry, is the interface between liquid and gas. So this is more of a physical, quote, reaction. It's more of a physical event taking place than a chemical one.
Got it. In this case, with it being like a physical change happening, would you spell physical F-I-Z-Z?
Oh, no.
It's a physical change.
I can never see those coming. Okay,
I was like, man, I got to hold on to this and put it at a good time because she's telling important stuff.
I don't know how you make those connections, but your puns are always very good.
Well, I have a lot of time on my hands just doing the listening part. You're doing the teaching part. So I've got time to think of jokes.
That's true. So the basics of this is about bubbles. Bubbles in general, it can be hard for them to form. They're made up of individual, in this case, carbon dioxide molecules. There's carbon dioxide in the solution in your soda. And the way a bubble forms is it has to fight against all the intermolecular forces of water that we've talked about are really strong. So water is holding on to itself pretty strongly. And then there's, one molecule of carbon dioxide that's trying to work and get to other molecules of carbon dioxide. And those will come together and form a bubble. If you can get enough of those carbon dioxide molecules together.
Got it.
So then when all those molecules do find each other and they form a bubble, eventually they can escape because they become so buoyant that they are light enough to overcome the strength of the intermolecular forces. So its buoyancy basically beats down the intermolecular forces and it allows it to rise up.
Huh. Weird.
But usually to make that happen, there needs to be a nucleation site. We've talked about nucleation sites a lot.
Yeah. It's
a place where a crystal can start forming, or in this case, it's something that can kind of break up the bonds between the water molecules and themselves, between all the different molecules of the water, and allow the carbon dioxide molecules to break through and find one another.
Okay.
And form a bubble at that nucleation site.
Okay.
Does that make sense?
Yeah, I think so. I mean, especially because you see would it count like when you see the bubbles forming on the sides of the bottle or whatever? Like, is that part of why they're doing that as well? Like the nucleation side is already there?
Yes.
Got it.
Or if you put a straw in, that kind of breaks it up. And so bubbles can form along straws. You can see that a lot. If you have like a clear straw and a clear glass.
Yeah.
So that's the basics of how bubbles form. You just learned about how bubbles form.
Nice.
Bubble science.
Are there bubble scientists?
I'm sure. What we've learned in this podcast is that there's a scientist for everything.
Yeah, exactly.
So in the case of dropping Mentos into a soda, what happens is that process is pushed into super speed because there are so many nucleation sites on the Mentos candy.
Oh.
The way we see it, it looks really smooth, but I found one paper where it zoomed in and you could see the ridges at a microscopic level.
Weird.
And the act of it dropping through the soda is breaking up those intermolecular forces between the water and allowing those gas bubbles to move more easily. So it's not only that there's nucleation sites on the Mentos, but it's breaking those intermolecular forces.
Wow. Huh.
So that's kind of the basics, but I have some more stuff that we can talk about. So do you want to stop back and kind of explain it back to me to make sure you're tracking with me?
Yes, totally. It seems like enough that I want to make sure I'm getting it right and fully understanding. So we've talked some about carbon dioxide and bubbles a little bit, like in baking. We've talked some about carbonated stuff in the past also. Right. And we've talked about intermolecular forces. There's a few things here that are things we've talked about. So there is already the CO2 in the liquid, in the Diet Coke or whatever soda works. But I think Diet Coke's like the strongest one for some reason.
Well, we're going to talk about that. Don't worry.
Oh, okay. Sweet. It's already there, and it's already being released on its own time, where the molecules of carbon dioxide are trying to find each other, and almost like with more numbers, they're able to get to a point where they can form a bubble and kind of like successfully push against the intermolecular forces of the liquid,
Right.
to kind of form a bubble together.
Mm-hmm.
Kind of like if you and your friends are like at a concert or something. If you're together, you can kind of like bunch together and push through the crowd or something like that, more successful than just trying to be one individual fighting against a whole crowd. It's not like a perfect analogy, but just the idea that with more people, you can have a stronger presence in something.
One analogy that I have thought of is when I think it's in Finding Nemo, and all the fish decide to collectively push against the net at the same time.
Oh, yeah.
Is that Finding Nemo? And then they can overcome the force of whatever is pulling the net in. It's kind of like that. You get enough bubbles, you get enough
I like that.
You get enough CO2 molecules together, and it forms a big enough bubble that it can rise up due to its buoyancy.
Yeah, it can form a bubble in the first place and then get to a point where it rises up and can be released.
That's right.
Interesting. Okay, so that's what it's doing. It's trying to get its friends together. Come on, we can do this, guys. We can fight this oppressive liquid that we're all trapped in. So they're trying to overcome that and be released all the time anyway. And what helps to be able to do that is having a gathering place or a nucleation site.
A gathering place. That's a good way to put it.
Hey, everybody, let's go meet at the pier or whatever. Everybody knows where the pier is, obviously. Makes it way easier to get everybody together instead of just wandering around hoping you'll find other people. There's got to be like a funnier. It's like, hey, everybody, let's meet at the soda parlor and then we'll go, paint the town red. So just like with crystals and some other reactions we've talked about, having a nucleation site like that lets either some reaction begin, or in this case, more molecules kind of find each other and link together or something, or...
Yeah, they collect together, and the reason they're able to join together is because the intermolecular force between water is broken up usually at that nucleation site.
Oh, yeah. It's already
so
done
I
for them.
imagine there's lots of water molecules holding hands, and then something pokes out and breaks them up a little bit.
Right.
And so they just can't form as well in that area. So then the CO2 molecules can come together in that area.
Got it. Or like on the inside of a straw or glass or something, it's something about the surface of that thing that's not the water, that's not the other liquid, that allows them to kind of break through that surface tension, intermolecular force stuff. Okay, so that's already happening all the time.
Yes.
In the average soda. And then you drop a Mento. What's the singular? A Mento in there.
I don't know. I would think it'd be Mentos. You drop one because it's like the candy is Mentos.
You drop the
like
Menti.
Reese's.
Oh, yeah. Well, Reese's, what's weird about that is it's plural. Is Mentos plural? I mean, it's not plural. Reese's is possessive. It's a family name. So I wonder if Mentos is a family name or if it's unrelated to that.
I have no idea.
Man, the Mentos scientists need to tell us what's going on there. So you drop one of those in there, and not only is it just the act of an object entering the liquid going to start disrupting some of those intermolecular forces, because just kind of pushing stuff out of the way while it drops down in there.
Right.
But also, surprisingly, the Mentos has tons of ridges and stuff like that all over it that we don't really see, but on the microscopic level are significant enough to where it's just like a bunch of gathering places all on one Mento, a bunch of soda parlors all on one little thing being plunged into there. And so all these CO2s can get together really fast, which would have taken them like maybe an hour or so to all find each other and form a bubble and get released. But now they can find each other really fast and then all go crazy, make bubbles and paint the town red and escape all at once.
That's exactly right. And that's why Coke and Mentos does the thing.
Dang, that's way weird. Like,
isn't it so weird?
I thought for sure it'd be like, I mean, I just didn't have any, even though maybe I should start being able to have some better hypotheses now that I've learned more chemistry stuff. But I thought for sure it'd be like, oh yeah, the makeup of this thing is a chemical that reacts with this chemical that like either changes the pH or I just didn't know. I just had no idea. But
yeah, I thought it was going to be an acid and base reaction, no problem.
And there's so many bubbles that it doesn't, to me, I just didn't think, oh, these are the bubbles that are already in there that could be formed and that like sort of come out over time and they're just happening all at once. Like that just never would have crossed my mind.
I know, it really is kind of surprising that that's what's happening, but I feel like it's so cool that it's,
yeah.
You can almost get a visual of how many bubbles actually were in there all along that we just didn't know about, kind of. Okay, so all that is really cool, I think.
Yeah.
So if you're not interested in it anymore, that can be your main takeaway. But there is more. So I found that a physicist had her class do an experiment on soda and Mentos to sort of give them an opportunity to do an experiment that didn't already have a solution. You know, it was a real research project. This information wasn't already out there.
Mm-hmm.
And so she designed it as that, and it got way more complicated than she initially thought. And she ended up publishing a paper on it, which I think is so fun.
Wow.
And that's what I did most of this based off of. But they went into details. It's not as rigorous as it would be in a research lab, but it is pretty rigorous in terms of an experiment done in a classroom.
Mm-hmm.
So they went into all this detail. They tested if anything could cause a nucleation site. And they found that pretty much anything would. You know, you could do a lot of stuff in there and you would get the same kind of reaction.
Mm-hmm.
But they found that Mentos worked best.
Hmm.
And the two reasons they think is because they have the nucleation sites available on them, but they also may contribute something chemically that helps break up the intermolecular forces between the water. Like there may be a little bit of that going on that dissolves in it, although that would happen really quickly.
Yeah, it's like so instant.
So it'd be pretty minimal, but also the density versus porosity is good. It plummets down to the bottom when you put that in there instead of gently floating down, you know? And they found something that had a good density that would plummet down to the bottom, plus having good nucleation sites is going to be the most effective.
Wow.
So you could drop some regular mints or something in there, but they would kind of float slowly. You know, the ones that have the open center like a Lifesavers mint.
Right.
It's not going to be effective. But they even had a graph of which ones went the best and all the different things that they tried. They tried Mentos and mini Mentos and all these different things. It was really fun. And then they also tested, why does it seem like Diet Coke works so well?
Yeah. That's what I've wondered a lot.
So Diet Coke has artificial sweeteners like aspartame, but they also have a preservative in there. And both of those things together also break up intermolecular forces between water or between the soda that's already going on.
Oh, huh.
So the diet soda seems to be more effective because those things make it easier for those sodas to bubble anyway.
What?
So bubbles can form more easily with those weaker intermolecular forces, and that's why they react stronger.
Right. And it wouldn't really seem like that to us just from, drinking them or whatever. Because we're not thinking about, man, this is so hard to drink. It's got so much intermolecular forces in it. Or it's got so little or whatever. But interesting. It kind of just primes the environment for mentos to go crazy in there.
I know. Isn't it crazy?
Yeah, seriously. Weird.
So that's everything. That's what I have for you to learn today. It's that Diet Coke and Mentos is just not even a real reaction. It's just a rapid release of gas bubbles that were already present in the soda.
Wow.
Isn't that crazy?
Dang, dude, that's crazy. That's a serious curveball.
It is a serious curveball. It was not what I expected at all.
And it's already a cool reaction. So like almost any explanation was going to be cool, but this was definitely cooler than I expected.
And it's fun that physicist went so in depth and learned all this stuff and tested all these things.
Yeah, that is fun.
You can tell it was a scientist doing it, and she was like, we're going to really dig in here.
Yeah. I've seen so many videos.
Enjoyable.
Sometimes I'll just get like really crave this kind of thing. So many videos where people just try to scale up experiments like this, like to the crazy degree. So they're not scientists. They're just people who are like curious.
Mm-hmm.
And so they get, a huge bottle that they can find that still has like a kind of bodily shape to it. And then they create a little thing so they can put a lot of Mentos in and then pull a like platform out so they all fall in at once. And I not maybe 2 or 3 weeks ago went and watched one of those crazy videos just for fun. I was like,
how funny that happened to coincide.
Yeah, really. It's like I just really wanted to see something like erupt in a pretty harmless way. I don't know.
That's all I have for you in terms of chemistry for this week. But is there something fun that happened in your week that you want to tell me about?
Yeah, I'm kind of gonna double dip on talking about him and I celebrating our 5th anniversary. He kind of like nailed it, overdid it on the anniversary gift. We don't have parameters about gifts like that. Part of the reason why is because our anniversary is super close to M's birthday. And so we typically don't really try to get stuff for each other for our anniversary. It's more like emphasis on spending time together, fancy dinner, some sort of really important quality time that we could do. But this year, in a real...
That's sweet.
Yeah, but it's also better because it's more fun than stuff,
Yeah, people are better than stuff for sure.
In a rule-breaking move, this year, Em got me a new coffee kettle, which I think, like, partly is because I'd been complaining about my other one a lot more and kept, like, deliberating about, like, oh, should I upgrade that part of my coffee thing next, or should I upgrade this other part? And I, like, will, subject her to all these rants about, like, what I should do next coffee-wise and stuff. And so I didn't think about it, but I was like, oh yeah, she's had to listen to a lot of that. And so she very, very sweetly got me a new coffee kettle, which is awesome. It works a lot better than my other one, which I had for like 5 years. So it was working. I mean, it was dependable for a long time. It had put its time in. So it's good to have a new one that's kind of more updated and just a little bit more reliable. So for some people that might seem pretty boring, but for me, it was like every day when I make coffee about 4 times a day, I'm like, oh man, this is awesome. So
that's sweet. What a good story. Way to go, Emily. Way to break rules and get an awesome gift.
Yeah, she's like, rules can't hold me down. Sorry, I don't care about your rules.
She's a quiet rule breaker though, it's like never expected. She's not like,
yeah.
Ranting and raving about the rules.
Totally. She's able to come across pretty instantly. It's like, oh, I just wanted to get you something. It's like, I can't be mad about that, but you did break the rules. That's me. What about you? How was your week?
Well, my week was good, but I have recently discovered something that is life-changing to me.
What's that?
It's hats. Okay.
Hats?
And that doesn't hats. And that doesn't seem like a big deal, but I hate the sun.
Mm-hmm.
The sun and I don't get along. It hurts my eyes. It burns my skin. I would rather be cold than hot 100% of the time. Other people wake up on rainy days and are a little bummed, and I'm overjoyed. And when I wake up and it's sunny outside, I get a little bummed feeling.
Yeah.
It's like somebody switched the wires in my programming.
Yeah, that's kind of weird. Although really intense sun and heat can be pretty rough. So depending on the season, I feel like there's a lot of people that might agree with you. Well,
my threshold, I feel like, is lower. I'm already tired of it being hot. and it's May. So
Yeah.
my roommate often sports a straw hat with a little black ribbon around it that's super cute.
Mhm.
And I had been wearing a baseball cap. I didn't even wear those until this summer.
Mhm.
And I realized I could wear them with my hair braided, and it covered up my messy hair and it protected me from the sun. And I was like, wow, this is amazing. But it really only looked good with my athletic clothes. And then I noticed this straw hat that my roommate was wearing, and I was like, I have to have one of those. And I saw a picture of one at Target. She was kind of trying to decide something and sent me a picture. And I thought about the hat that I saw for a whole week. And then I was like, okay, if I still want it this bad after a week, I'm going back and getting it.
Yeah.
And I went back and it was there and I got it. And I'm so excited. It's such a cute hat. So I actually got a big floppy hat and then a less big straw hat that I can wear at more normal events. The big floppy hat is more like a pool beachy type hat.
Got it.
And I absolutely love both of them. And I've worn a hat every single day since I got these hats, and I never want to stop wearing hats. I don't know how it took me 29 years to figure it out, but it's like hats were made for me.
Yeah.
I don't understand.
Well, and what's worth noting, if maybe you already said this, but your skin's pretty reactive to the sun. But at the same time, all of us should be doing whatever we can to keep our skin from, just straight up UV exposure. And so
That's so true.
So protecting your skin is cool. Hats are cool for two reasons. They look cool and they protect your skin. That's very in. Kids.
So in. That's so in. So I'll post a cute picture of me in one of my hats that I'm so excited about.
Sweet. That's awesome. I also like hats. I don't wear the big straw ones or whatever, but I get the excitement around a hat, new hat, or like, I don't know.
Oh yeah, you had your cryptozoology hat or to support small businesses.
Yep. And I also had, like, at a similar time, I got a hat that was just a lot more durable for specifically like, being outside or something, or going on a trip or something like that. And I was like, this is so nice. Like, it's so nice to have a hat I'm not going to be worried about. Like, it's water resistant too. And it was just like, it's still a baseball cap, but it's like, this is great. Fits more environments, fits more situations. It's like weird to get excited about, but I totally get your excitement.
Well, okay, listeners, if you guys have a hat that you love and that you're so excited about, post a picture of you wearing your cute hat and tag us in it, and we'll retweet it or add it to our story or whatever.
Absolutely.
Because we love hats, apparently, here at Chemistry for Your Life.
Yep. If you love hats, then you're among friends here.
Well, thanks so much for coming to learn about why Cook and Mentos do that thing. Thanks, Katie J, for your suggestion. What a great idea. Great question. I loved the wording of it. It's perfect.
Me too.
And thanks to all you listeners for coming and learning about how we love hats and how Cook and Mentos do that thing.
Melissa and I have a lot of ideas for topics of chemistry in everyday life, but we want to hear from you. So look around at the world, at your life. What are the things you wonder about that Coke and Mentos, about something you do every week or every day? And send us your questions and ideas. You can reach us on Instagram, Facebook, email, Twitter at Chem for Your Life. That's Chem, F-O-R, Your Life, to share thoughts and ideas. If you enjoy this podcast, you can subscribe on your favorite podcast app. And if you really like it, you can write a review on Apple Podcasts. That helps us to be able to share chemistry with even more people. If you'd like to help us keep our show going and contribute to cover the costs of making it, go to ko-fi.com/chemforyourlife and donate the cost of a cup of coffee.
This episode of Chemistry for Your Life was created by Melissa Collini and Jan Robinson. References for this episode can be found in our show notes or on our website. Jan Robinson is our producer, and we'd like to give a special thanks to S. Flint and V. Garza, who reviewed this episode.